So glad you stopped by. So anyway, as I was saying, Robert, Robbie, Bobby, Bob, let's go with that. Try to make these videos somewhat entertaining, for the students. Really do, while at the same time trying to get information in there they need in order to learn the math and be able to do the assignments.
Oh, that's really cool. I appreciate the kind of complexity of it.
So back when you were in high school, you were a big fan of math and math class, right?
Sure.
Yeah, that's cool, man. I was talking with our principal, Dr. Guthrie, this week. You did know that he graduated with his doctorate, right?
Yeah, he's becoming a better guy.
Yeah, we were talking about, we've got all these lessons out there, all these great lessons, and some students they're skipping the videos and just going straight to the assignments and trying to do the assignments without ever learning the lesson. I mean, that wasn't you in school, right? You were one of the ones that paid attention to the lesson, right?
Sure.
Yeah, some of the students, they're really sharp in math, and they don't have a lot of problem doing that. If there's something they don't understand, they look it up on the internet, and they seem to do okay. But there's a lot of these students that, man, they have no idea what's going on. You can tell by what they make no sense with the answers they put on there. They really need to be watching the video.
Are we promoting a movie?
Oh, sorry. Where was I?
Your foot's starting to jump a little bit. You better get to your next question.
Right. So we're just about to wrap up the school year, and
What are we doing?
oh man, it's late. I got to do a lesson. I got students waiting on me. I'm sorry. I got to run.
Bye.
Oh, cue my intro. Before we get started on this week's lesson, I want to review something from last week's lesson. So I want to go to show this on the screen here. Okay, so we had this equation on our lesson last week, and I asked lots of questions about it. It was what we're asking: relative minimums, relative maximums, domain, range, decreasing intervals, increasing intervals. And I saw a lot of people struggling with the intervals. I mean, just look at the graph. Right now, I have no points up there. I had points on there where you can see some of those points. But just looking at this right now, I'm going to take a picture of this where I can write on it. All right, so there's a picture of this. Where is it increasing? What intervals is it increasing? Is it increasing over here when x is -2 and -4? No, it's going down as the x's get bigger. It's going down, down, down all the way until this point right at the bottom. And now if we watch, it's growing. Now it's increasing, but it stops increasing when it gets right there. It doesn't increase past that point because now it's going back down. But after it goes back down, it starts increasing again. So this has two places where it increases, right? You see it increasing in two different areas of the graph. So what are those intervals? Intervals is it's increasing from this point to this point. That's the intervals we'll talk about. So look at this first one. It increases from the time the x is -0.366 all the way until the x gets to 1.366. That's how long it's increasing from this x to this x. So again, if I take a picture of that so I can redo it, it's increasing from this point to this point. Now, the other number there is the value. It was at -5 and it went up to -0.6. That's an increase. That is the actual increase, but where is it increasing from? If I write my answer down, it increases from -0.366, comma, until it gets to 1 point. I'm writing it sloppy with this because I hate writing with this thing. I'm not good at it yet. This is the area it's increasing right there. It increases in that interval. An interval means a gap, a time period. It's marked by two boundaries. So the boundary is from the time it is at -0.366 all the way until it gets to 1.36. That's when it's increasing. Now there's a second time it's increasing. So we're gonna have another parentheses over here with another one, because it also increases from 2. See, it was going down until it got to 2. And at 2, it stops going down and goes up. And it goes up how long? When x is 2.48? No, it's still going up past 2. How about when x gets to 3? Is it still going up when x gets to 3? Oh, yeah, it passed 3 up here. See, it's bigger than that. How about when x gets to 8? Is it still? Yeah, it's going up forever. If we keep going up the graph, we'll see it keeps going up, keeps going up. So the second interval starts at 2. Just up there. Starts at 2 and goes all the way to infinity. So that's the two areas where it's increasing. See, it's increasing over here forever. But that's the intervals from 2 to infinity and from -0.366 to 1.366. And we can mark those with our highlighter, go from there and from there all the way up. The other intervals are where it's decreasing. The decreasing is all these x's down here. During all that time, it's going down. It's decreasing. So from negative infinity, it starts at negative infinity way out here. Oh, that's not an infinity. Where's my eraser? There. That's infinity. From negative infinity, as it continues getting larger, this graph is still going down all the way until it gets to that. So it's decreasing from negative infinity until it gets to this point right here. That's when it stops going down. -0.366. It's not going down anymore at that point because it stopped there, and now it's an increasing interval. But when it gets to that point, which I didn't even mark yet, right there, 1.366, between there and 2, it's going down. See, it's going down between 1.36 and 2. So that's our other decreasing interval. And 1.3. So from 1.366 until it gets to 2, these are both decreasing intervals. So there's 2 intervals where it goes up and there's 2 intervals where it goes down. So when you're doing intervals, you have to have a boundary of an interval. An interval is a period of time or a space. You have to have something that marks the beginning and something that marks the end. And so that is what that is for. All right, I'm going to get rid of all of that. But we had that one, and it was really, a lot of people were struggling with intervals. And intervals, an interval has a starting point and an ending point. That's an interval. An interval of time would be, it starts at 12 o'clock and it ends at 12:30. That was an interval of time. You know, an interval. So give a starting and an ending point for your intervals. All right. That being said, let's get into this week's lesson. We're going to talk about, continuing on from last week, we're looking at key characteristics of polynomials, which is intervals and turning points and all of that stuff. Now we're going to look at the zeros. The zeros. So the point at which the function intersects the x-axis. That is a zero. That's what a zero is. The point at which it intersects the x-axis, which if we look back, well, I think did I leave that open? Yeah. See, this has a 0. I'm going to turn these off. It crosses the x-axis right there. So there's a 0 at negative 1.052, and there's a 0 over there. Those are both zeros because it crosses the x-axis, or it touches the x-axis. It intersects it. If it intersects, it means it touches. It touches the x-axis at those 2 points. There are 2 zeros right there. A polynomial function of degree n, right? The degree is the largest exponent, can have at most n real zeros. So if I have something that is x to the 5th, it could have 5 real zeros. Could cross the x-axis or touch the x-axis 5 times. It can't do 6 if it's only a 5th degree equation. 5 is the most it could possibly touch the x-axis. An even degree polynomial has an even number of zeros, or none at all. An odd degree has an odd number of zeros. That makes sense? Makes sense? This is an odd. It has an odd number of zeros. All right, this is to graph each function and identified zeros. So we're going to go ahead and use Desmos. We could graph it by hand if we want to make an XY table. But since we have the option of using Desmos, let's go ahead and do that. All right, so let's take away this equation. So this one is, make that words a little bigger. F of x equals x to the 3rd plus x squared minus 2x. All right. So I'll go ahead and kind of sketch what that looks like on our graph here. All right, so we kind of have a drawing of what it looks like over here. But let's talk about the zeros. If we zoom out, that's the only place it touches. It goes on to infinity and negative infinity from there. And at this point, I actually lost the audio of the original video, but I can tell you what is going on here. I'm looking at the actual zeros for this equation using the Desmos graph. So we can see that there's a 0 at negative 2. There's a second 0 at 0. And there's a third 0 when x equals 1. So the 3 zeros for this equation are at negative 2, they're at 0, and they're at 1. It's an x to the 3rd equation, so we shouldn't be surprised that there are 3 zeros. And we can see that it crosses at all 3 of those. It'll cross at negative 2, it'll cross at 0, and it will cross again at x equals 1. All right, so we'll be moving on to the next problem here in a moment. I don't know what else I'm talking about other than saying that's the 3 zeros. So, okay, we're going to graph the next equation. So we're typing the next equation into Desmos. That equation is negative x to the 4th plus 4x to the 3rd minus 2x squared minus 4x plus 3. And that's what the graph of that looks like. So we can look at this. Desmos marks the zeros for us. So as we zoom in there, we can see there's a 0. All right, so when we graph this one, the negative x to the 4th, we know it can't have more. 4 is the maximum number of zeros it can have. That's the most it can have. And when we graph it, we see it actually has 3. And we're going to talk about why there's only 3 here in a minute. Negative 1, 1, and 3 are the 3 zeros that we have for this equation. If we kind of graph that, negative 1, 1, and 3. Okay, just kind of put it on our notes there so we have kind of a picture of what that graph looks like. So that is the zeros for this equation. Let's talk about the linear factors. And when we factor these equations, we learn something about why a 4th degree function only had 3 zeros. So let's factor this. Let's write this equation, and it's factored for. I'm going to make that bigger where we can kind of see it. So if we factor this out, the first thing we see is we can pull an x out because all those have an x. X squared minus 2x minus 15 when we factor an x out of it. Now we can factor that quadratic x. If it's minus 15, we need two numbers that multiply to be minus 15, that when we add them together, it's minus 2. So if we do x minus 5 and x plus 3, that multiplies together. Negative 5 times 3 is negative 15. And when we add negative 5 plus 3, it's negative 2. So this is how it factors. So writing this equation in factored form gives us this. And if we want to know what's the zeros, if we set that equation equal to 0, 0 equals this equation. And then we factor it to where this equals 0. That means x equals 0, means x minus 5 equals 0, or x plus 3 equals 0. All of those are places where it would equal 0. Because if we're multiplying these three things together and it equals 0, one of those has to be a 0. There's no way you can get a 0 unless one of these is 0, because we're multiplying all three of them together. So that means either this one's 0, this is 0, or this is 0. Well, if this is 0, that's one of our zeros. X equals 0. If x minus 5 equals 0, x minus 5 equals 0, that means we add 5 to both sides, means x equals 5. That's a 0. Because 5 minus 5 would equal 0. So x plus 3 equals 0. X plus 3 equals 0. Minus 3. X equals negative 3. So negative 3 is our third 0. So there's the 3 zeros for this equation. And it's a third degree, so we would expect no more than that. 3 is the maximum it'd have. X to the third. So let's take this a step farther. Let's go to page 2 of the notes. We have another one. We're talking about the multiplicity. Multiplicity. The multiplicity of a 0, and like, wait a minute, I recognize part of that word. It means how many times it multiplies would be the multiplicity. Is equal to the number of times its corresponding linear factor occurs. So let's factor this, and maybe that'll give us a better idea of what in the world are we talking about with multiplicity. So the first thing we can do is, again, there's an x in every term. So we'll factor out the x. It equals x times, so when we factor an x out of the first term, factor an x out of that, factor an x out of that. Now we just have a quadratic equation to factor, and we need it to equal 9 and add up to negative 6. So that's the same thing as x times x minus 3 times x minus 3. Negative 3 times negative 3 is 9. Negative 3 plus negative 3 is negative 6. So this would be our zeros. If this was equal to 0, x would be 0. And there's only one of them. Multiplicity 1. I didn't write that real well, but my L and I kind of went together. This one is x minus 3, x minus 3. So if x minus 3 equals 0, that means add 3, x equals 3. And the other one is 3, and it has a multiplicity of 2. So it means the zeros are 0, 3, and 3. There's 2 zeros in the same place. It has a multiple of 2. The multiplicity is 2 because there's 2 of them. You're like, what do you mean there's 2 of them? Well, let's look at the graph of this equation. All right, so if we look at the graph of this, I'm going to kill these that we had here. All right, f of x equals x to the third minus 6x squared plus 9x. All right, let's look at the graph of that. There's the 0, and there's the 3. Now notice what happens. Since this is there's just one 0 adhering, it'll cross the x-axis. This one has 2 zeros at 3, So it doesn't cross, it just touches it. It touches it and backs and bounces back off of it. See, we zoom in, we see it touches and then it goes back up. On either side of it, it's bigger than 0. Bigger than 0 on either side of that. That is the smallest point. It becomes a relative minimum, basically. At 3, it becomes a relative minimum. So that's why we see. So that tells us that back on this other page, when we graphed, let's switch back. When we graphed on this other page, this one, and we only ended up with 3 zeros, there is 4, but it turns out this middle one that bounces at 1, there's 2 1s because it bounced off the x-axis. It just touched it there, but it didn't cross. So the 4 zeros for this, if we factored it, we would find it's -1, 1, 1, and 3. Which that's why it did that, why there was only 3 visible, because one of them was duplicated. There's 2 of those. So right into that, how multiplicity affects a graph. All right, so this is the same equation, So it wants us to graph that, which we just did on Desmos right there. So we see it's at 0 and at 3, and it comes down, bounces off, and then crosses, it goes down. All right. So we go back to our paper. If I'm sketching that on here, make it in red, make it a little easier to see. When it hits 3, it bounces and then crosses actually at 0. If the multiplicity is odd, which means there's 1, right? Odd, 1 or 3 or 5, maybe we have 3 zeros. It's still going to cross at that 0. It's going to cross at the 0 if the multiplicity is odd. This is even. So if it's even, if there's 2 of them or 4 of them or 6 zeros all at the same 0, they factor to be 2, 2, 2, and 2. Then it just touches, or I'm going to say bounces. It touches or bounces at that 0. It touched it. It just bounced right off of it. Hit 3 and bounced right off of it. Stayed on the same. If it was coming up, it would have bounced off of it downward. That's why I said bounce. It'll just bounce off of it. All right, so let's do some examples here. This is already factored form for us. Thank you. That made it nice on this one. They didn't do that for us here, but they did it for it here. So we see that x plus 7 squared is one of the zeros. Because if we set this equal to 0, either this is 0 or this is 0 or this is 0. So since it's x plus 7, that 0 is at -7. All right. X plus 7 equals 0. We subtract 7 from both sides. X equals -7. That's one of the zeros. The multiplicity. All right. The reason this says x plus 7 squared is because actually it would factor to x plus 7, x plus 7, which is x plus 7 squared. So this has a multiplicity of 2, which just means it will bounce or touch, whichever way you like it. It's just going to bounce off the x-axis because there's 2 of those. 2x plus 1. What's that going to be? 2x plus 1 equals 0. Subtract 1. 2x equals -1. Divide by 2. So this has x equals -1/2. We divide by 2. So we have a -1/2, 0. And it has a multiplicity of 1. There's only one of those. So it will cross the x-axis. Now we have x minus 4. So that must be a 0 at 4, because 4 minus 4 is 0. And look, it's to the 3rd power. So there's an x minus 4, x minus 4, x minus 4. Has a multiplicity of 3, which means it will cross at that 0. So let's double check to see if we're right. So we can take this and put it in the Desmos. F of x equals, and the first one was x plus 7 squared, and we can type it just like that. Let's just type it in factored form. Okay, there's x plus 7 squared, and then we have 2x plus 1, and then we have x minus 4 to the third power. All right, there it is. X plus 7 squared, 2x plus 1, x minus 4 to the third power. And let's look. Oh, interesting. This one just ends there, but that is a 0. -7. It bounces. It doesn't really just end there. It's actually bouncing. If you get in there, see it's 2 lines. It's very, very close together, the way that graphs. We just have to zoom in to see that. Let me zoom back out so I can go back down to the bottom. If we zoom in, we can see it is bouncing off of there. You just got to get in there quite a ways before you see that. There it is. See, it just bounces right there at -7. And then these over here, as we zoom back out, then this one is a 0 at -1/2 and 4. There's our 3 zeros. So when we look at that, we said -7 had a multiplicity of 2, and it bounced, which it did. -7, it bounced. At -1/2, it crossed, and at 4, it crossed. -1/2, it crossed, and at 4, it crossed. So we double check it on Desmos and say, yep, we're absolutely correct. That is the right answers. 3 zeros, but 6 zeros altogether. There's just repeats, multiplicity. All right, we've got 2 more examples, and I'll let you guys go today because I'll show you our assignment. This one is not factored for us, so let's factor it. We see that there's an x squared, and these are all bigger than that, so I can factor out an x squared, which will make this x squared minus 2x minus 8. So if we want it to be -8, 2 numbers that multiply together, -4 and +2, they would add together to be that. Factoring practice here too. X minus 4, x plus 2. Okay, that's fully factored. Our first 0, if this was all set equal to 0, that means either x squared 0, x minus 4 0, x plus 2. So this is just x equals 0, right? Because 0 squared is 0. Has a multiplicity of 2, so it will bounce off the x-axis at 0. X minus 4, that's a 0 of +4. There's only one of those, so it'll cross. And x minus 2, x equals -2. -2 plus 2 is 0. There's one of those, and it will cross. Again, let's double check ourselves really quick. This won't take long. It was positive x to the 4th. X to the 4th minus 2x to the 3rd minus 8x squared. Okay. -2, it bounces at 0 and 4. Bounces at 0 and then -2 and 4. Bounces at 0, -2 and 4. Okay, we got that right. Here's the last one we got. This is kind of fun. Don't be intimidated by a word problem. This should not be hard. If you understand this and how we got the zeros, you can do this. So a polynomial function has a 0 at -6 that has a multiplicity of 2, and a 0 at 2 that has a multiplicity of 1. And they want us to write a polynomial function in standard form that can represent this function. All right, well, first we're going to write it in factored form. We're going to write in factored form. In fact, I may change that in our assignment and just let you write that in factored form. Because The key is the zeros, not whether or not you can factor and go from factor to standard. If there is a 0 at -6, x equals -6. To make that equal to 0, we add 6 to both sides. So that would be x plus 6 equals 0. So that is one of our factors. X plus 6. And it has a multiplicity of 2, which means there's another x plus 6. There's 2 of those. And then there's one at 2. So if x equals 2, that means x minus 2 equals 0. So there's an x minus 2. So that is written in factored form. We can simplify that, though. It really is not simplified. If there's 2 of these, that's squared, and then x minus 2. So that would really be the factored form, x plus 6 squared. To write this in standard form, you just multiply these together. And you'd end up with an x to the third equation, because you have x times x times x. And so you'd have a longer equation here. But I'm going to leave this in factored form for this week. Just factored form. I'll look at our assignment, and if it has it standard, I'll change that. But just, can you write the factors given the zeros and the multiplicities? So let's look at our assignment this week. All right. It looks like a lot of problems, but like, this is one problem. There's 9 answers. What is the first 0 for this function? And this is already in factored form. X squared times x minus 1 to the 4th times x plus 5. So you enter the first 0 that you see, and then enter what is the multiplicity of that 0. How many of those are there? And the effect. And I made that multiple choice. Does it cross the x-axis at the 0, or does it just touch it and bounce off? Okay. Then what's the second 0? What's the multiplicity of the second 0? What's the effect there? Third 0, multiplicity right there. So you meant to scroll up. This scrolls off the screen, so you have to scroll back up to get it to come back on the screen. I wish that would stay on the screen, but it didn't. So after you get those 9, here's another one just like it with a new equation. -2x times 3x plus 1 squared plus x plus 7 to the 7th power. Again, what's the 0, multiplicity, and effect for all of those? Then I give you one that's standard form. So you are going to have to factor. You've got to factor that. And then what's the first 0? What's the multiplicity effect? Second 0. And I don't know when it factors. Is there 3 zeros? You won't know until you factor it whether or not there's a third 0. So if there's a third 0, you list that. If there's not, you just put NA. If there's not a third 0. Multiplicity, and what does it do? Does it cross? Does it touch? Or is there not a third 0? Then the next one, another problem that you have to factor first. This is an x to the 4th power. I didn't give you a 4th 0 because I know there's not 4, but I did give that choice. Is there a third one? So you're just doing the same thing on all of these first problems. Then you've got at the end, you got 4 of those, and at the end you have these 3 questions. Write the following equation in factored form. So that's just having you factor that. Then what are the zeros for the equation up here? The one you just factored, what are the zeros? And then here's that one like at the end. I'm going to change this. I'm going to change this where it's not going to say standard. I'll say factored. This polynomial function has zeros at 5 halves, which is the multiplicity of 2, 3 multiplicity of 1, and 0 multiplicity of 4. Write a function, and I'm going to change it to factored. Factored form that can represent this function. Okay, so you may need to go back and look at our notes. It's like 5 halves. Yeah, we dealt with some up here that had a 0 that was a fraction. This one had a 0 at -1/2. So could you go backwards from having the 0 back to getting what would the factor be? 2x plus 1 would have been the factor. 2x plus 1 is the factor. That would be equal to 0. That would say x equals -1/2. So, all right. That's it. And that's the last question right there. So like I said, I'll change that one to factored form. So you don't have to worry about multiplying. I'm not checking this week. Do you know how to multiply factors together to get an equation? Not worried about that. So, okay. Questions on that? If you had trouble with 4.1 last week, go back and fix that, because I talked about those intervals where people were struggling with. If you need to go back and review this video, I'll try to get it posted as soon as I can here. It's got a process and all that good stuff before I ever have access to it, but I'll get it as soon as I can. And that'll be it. We will see you Wednesday. And if you need to be here, it's A Day this Friday. So we'll see you then if you need to. If you have questions, you can come by, even if you don't have to be in class. We will see you guys.